Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. The quality of a fiber optic link is of paramount importance since any fiber optic network could potentially carry life safety and/or mission-critical information at some point. Thus, cabling standards have been developed to ensure this quality. This video explains the concept of a standard in general, how standards benefit the fiber optics cabling industry, and covers the two main categories of cabling standards used to certify optical fiber links. A standard is defined as a set of rules and guidelines that are used as a basis for judgment. There are standards for every industry imaginable, but since OWL manufactures fiber optic test equipment, this video will focus on the standards that apply to the fiber optics test and measurement industry. Cabling standards are developed by several national and international organizations that are dedicated to performing research and development activities related to the formation of cabling standards. Perhaps the most well-known cabling standard in the United States is the Telecommunications Industry Association, or TIA, which is a subset of the Electronic Industries Alliance, or EIA. Originally developed in 1991, the TIA-EIA 568 cabling standard is the primary standard for certifying commercial building networks in the U.S. The International Organization for Standardization, or ISO, is an internationally known cabling standards organization. Best known in the IT industry for its OSI, or Open Systems Interconnect, 7-layer network model, the ISO also developed the ISO 11801, which is very similar to TIA 568. In fact, it is a common practice among standards organizations to share information, or refer to each other's standards. Finally, the Institute for Electrical and Electronic Engineers, or IEEE, is a professional association that focuses on the electrical, electronics, communications, computer engineering, computer science, and information technology industries. The IEEE is perhaps most well known for its development of Ethernet, which has long been considered the most prevalent local area network protocol in the world. The main purpose of fiber optic cabling standards is to determine network limitations and expectations of the application, determine test parameters that accommodate limitations and expectations of the application, and to determine proper test procedures to use. The end result is the ability to develop an optical link budget used to certify a fiber link against the requirements of the application for which their standard was written. In other words, certifying a fiber link determines whether or not the link will pass or fail against the chosen standard. Overall, the most important benefit of using a cabling standard to certify a fiber optic network is to ensure that the network can support the application for which it was designed, installed, and tested, thus ensuring the quality of the network, which is of utmost importance to life safety and mission-critical applications. Cabling standards also benefit the industry by developing common test procedures to ensure consistency in measurements, as well as defining common terminology to ensure everyone has a consistent understanding of test methods and test results. As we have seen, the whole purpose of any cabling standard is to define a set of rules and guidelines that determine the quality of a fiber link. From a testing standpoint, standards determine how much optical loss a fiber link can withstand before it will no longer perform as specified, also known as a link budget. In the fiber optics industry, cabling standards can be loosely grouped into one of two main categories: application standards and generic cabling standards. Generally speaking, application standards are mainly concerned with the electronics used for transmission, such as network cards, hubs, switches, routers, etc., while generic cabling standards are mainly concerned with the physical configuration of the network, in other words, optical fiber, patch panels, and splices. Let's go into a little more detail about each type of standard. Application standards are developed with only a specific application in mind. Ethernet is perhaps the most well-known set of networking applications in the information transport systems industry. There are many flavors of Ethernet, each with a different set of transmission parameters, and thus each with a specific link budget. The drawback to using an application standard would be that it can only be used to test a fiber for that one and only application. for example 1000 base SX. The advantage here is that any 1000 base SX link can be tested as long as the physical cabling does not exceed certain maximums, typically fiber length. Generic cabling standards, on the other hand, are called generic because the physical configuration of the cabling is used to determine the link budget. Generic cabling standards can be used for any application as long as the application can fit into the link budget. For this reason, generic standards are by far the preferred method of testing fiber links. The most well-known generic cabling standard is the TIA 568 family of cabling standards. The TIA 568, like all other generic cabling standards, defines per unit loss values for three main passive components in the fiber link: fiber loss, connection loss, and splice loss. Fiber loss is given in dB per kilometer and varies with wavelength and/or fiber type. Connection loss is given in dB per connection. A connection would be a patch panel, wall outlet, or another type of mating sleeve such as a consolidation point. Splice loss is given in dBs per splice. Most generic cabling standards do not distinguish between fusion and mechanical splices. Adding together these three loss values determines the total end-to-end insertion loss that a fiber link can withstand before the fiber link will no longer perform as specified in the chosen cabling standard. When choosing a cabling standards to use for fiber certification, it is important to understand the advantages and disadvantages of the different options available. When in doubt, always default on using a generic cabling standard, since generic cabling standards can be used for any application. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more instructional videos, or to learn more about OWL's products in general, please visit owl-inc.com. I'm Professor Jim Powers. Thanks for watching.